Here's another example of solving a linear equation that has fractions in it. Again, there's sort of two ways to do this. We can either decide to get rid of all the fractions right at the beginning, or we can hang in there as long as we can with fraction operations. So if you like the idea of getting rid of the fractions as quickly as possible, then what you want to do is think about what can you multiply on both sides of this that will cancel with the denominators that's there. So you need to find the least common multiple of the denominators that you see in the problem. So in this case, one denominator is 8 and one is 4, and so 8 is actually a multiple of 4, so 8 is a multiple of 8 and also a multiple of 4. So if I multiply both sides of this this equation by 8, I'll have 8 times the left side equals 8 times the right side. Now, the point of multiplying is that the multiplication will cancel with the denominator of the fraction, because remember the fraction bar means division. So on the right-hand side, I'm multiplying by 8, and I'm also dividing by 8. If you want to think about it as the fraction operations we talked about, think of that as multiplying by 8 over 1, which means that in the numerator I'll have 8 times 3, and in the denominator I have 1 times 8. And you can cancel a common multiplicative factor. So in this case, that would be 8. So 8 is a multiplicative factor of the numerator and the denominator, so we can cancel it. Anyway, so on the right-hand side, I just have 3x. On the left-hand side, I don't know what I have until I distribute this multiplication. This 8 gets multiplied through these parentheses. So I'll have 8 times 1/4 x minus 24. 24 being 8 times 3. So just like before, I can cancel something. In this case, I've got to be careful because I have an 8 here and a 4 here, so they don't just cancel each other. The 8 divides into the 4 to give me 2. One way I can think about that is that the 8 is 2 times 4, so in the numerator I'll have 2 times 4 times 1, and the denominator I just have 4. So of the 2 times 4 in the numerator, it's going to cancel with the 4 in the denominator. So 8 times a fourth is 2. So after multiplying both sides by 8, I've eliminated the fractions, and I have an equation that's just 2x minus 24 equals 3, which is much easier to work with. And in fact, if you subtract 2x from both sides, you'll see that negative 24 equals x. So that is the solution to the equation. And since that's a nice whole number, that's very easy to plug in. 1/4 of negative 24 minus 3. That's negative 6 minus 3 is negative 9. And on the right-hand side, compare that to 3/8 of negative 24, which is also negative 9. So when I plug negative 24 into the original equation, I get the same thing on both sides. Okay, so let's suppose that, that we didn't like this idea of multiplying on both sides to get rid of things. Because here the terms are all separated, I have some x terms and some non-x terms, there's no reason I can't just treat this like a normal fraction problem, a normal equation, and put my x's on one side and my non-x's on the other. So for example, if I started off with 1/4, I'll just rewrite the problem here, so 1/4 x minus 3 equals 3/8 x. So I might subtract 1/4 x from both sides. If I do that, on the left side, I'll just have negative 3. Obviously, I've subtracted it away. On the right-hand side, I have 3/8 minus 1/4. So 1/4 is the same as 2/8. So on the right-hand side, I have 3/8 minus 2/8. So 3/8 x minus 2/8 x is 1/8 x. So by subtracting 1/4 x from both sides and actually doing the arithmetic here, the 3/8 x minus 1/4 x, with a common denominator of 8, I'm able to rewrite this equation as negative 3 equals 1/8 x, and then I can multiply on both sides by 8, so times 8. If I multiply both sides by 8 now, I have negative 24 on the left, and 8 times an eighth is 1, so I have just x on the right. So again, I end up with in the same place, but I can get it using the conventional means of just moving x's to one side and non-x's to the other side, but the problem with that is that I have to be able to do fraction addition and subtraction. Or I could just multiply both sides by the least common multiple of the denominators in the problem and get rid of the fractions all at once. Now, the problem with that is that I have to be careful about the distributive property, and I have to know what happens when I multiply a number like 8 times a number like 1/4. My expectation is that it should cancel out and give me a whole number. But if that part seems hard to you, then perhaps this way of doing it will make more sense. So either method is fine. We get the same answer either way.